Okay, students, welcome back. Welcome back for another lecture. In this lecture, we are going to talk about different operating modes of IA32 and Intel 64-bit microprocessors. So, IA32 or Intel 32-bit microprocessor supports three different modes. The first one is rail mode, protected mode, and system management mode. So first of all, we should talk about what is a mod or mode of operation. If you recall the earlier lecture which we conducted last week, we talk about the programming model of a microprocessor. So a programming model tells you the same thing, like what things a microprocessor exposes for a system programmer. It tells you like the ISA of the microprocessor, the instructions which are exposed and available to a programmer, the different architectural features which are accessible and available for a system programmer. So modes of operations actually tells you the same thing. Like as you saw in the previous slide, there the 8086 microprocessor or Intel IA32 or 64, we'll see shortly. These processors offer different operational modes. So what happens when a processor runs in a mode, like say in rail mode? Okay, it exposes a certain set of features, and if it shifts to another mode, like we say in protected mode, it exposes a different set of features for a system programmer, for an application, for an operating system. So first of all, we'll talk about let's talk about rail mode. Rail mode is, and then we'll see protected mode and system management mode one by one. So rail mode actually the earlier microprocessor, like which was developed in 1972. I'm talking about 8086 microprocessor, 8086. This is the default mode. Okay, and in this particular mode, the maximum available RAM or the main memory which is available for an application is up to 1 megabyte. That's all. You cannot actually extend and go beyond to this particular memory size. This is a upper limit. Even let's say that you have more RAM installed in your computer, but if your microprocessor is actually running in this particular operational mode, then you'll not able to go beyond this limit, 1 MB of size. And there are a few other things like when you boot up your machine, like traditional legacy computer, like I'm talking at the moment IA32 microprocessor, the boot up mode of any x86 processor is basically rail mode. So it means that in that particular mode, the operating system cannot access any memory more than 1 megabyte. So you can see that these days 1 MB is nothing. So the question that may come to your mind is, why do we still have this mod available in microprocessors, right? So hold on for a moment, we'll see shortly. And however, all, as I mentioned here, all latest operating system like Windows or like Linux, all these operating systems actually work in protected mode, that we'll see shortly. Okay, but with the passage of time, after 1972, the scientists and the engineers who were working to develop microprocessors, like in Intel organization, so they came up with a new mod back in 80 to 86 microprocessor, and that mod was actually protected mod. Okay, and in 64-bit machine we do not have any rail mod operation. So for those microprocessors will definitely need emulators that can actually emulate 8086 applications. So the question that I asked you about, why still do we have this particular mod? So the answer is quite simple: for backward compatibility. We still have few applications that need to be operate in some scenarios in like 16-bit 1 MB 8086 rail mod. So in order to support those applications, those legacy applications, my Intel still offers this particular mod in IA32 processors. Soon, as we discussed, Intel researchers design a new mod named protected mod. So with the help of protected mod, what happens actually, we can access memory beyond 1 MB, right? So that is a one very important feature when 286 and 386 came into the market. So actually it was a very awesome feature that was provided by Intel processors, that protected mode feature, like the microprocessor could operate in protected mode, and then application developers can access memory beyond 1 MB. So it was a big achievement at that time. And this is the as I said earlier in the previous slide, most operating system these days like Linux, Windows, they operate in protected mode. So these days the protected mode is the native state of the microprocessor. Mostly microprocessors are running in this mode. I'm talking about Intel hardware at the moment, not like any other hardware like ARM or some other chips. And in protected mode still we have support for legacy rail mode. So all programs that work in rail mode will continue to work in protected mode without any change. So in protected mode, the Intel gave an option, a feature which was still, in fact, which is still available in IA32, and that is about virtual 8086 mod. With this mod, actually this is not a mod, this is a feature of a processor. Okay, so with this mod, you can actually execute legacy 8086 applications that were supposed to be run in 16-bit and rail mod. So this is again supported with for the backward compatibility. Okay, now the third mod is system management mod, and as the name says that this is a special purpose mod, and which is used to we used to perform like some platform specific activities. And what could be those platform specific activities we'll see in a moment, but before going to that thing, let me introduce let me tell you that Intel introduced this particular mod back in Intel 386 SL series and Intel 486 SL series processors. And still today IA32s and Pentium processors support this mod. Okay, so what was the reason? The reason was the power management. There are many when you are running a processor, so there are different tasks which are related to the microprocessor itself, like how the power will be managed. Okay, or like for example, you want to monitor the health of the microprocessor, like for example whether it is heating a lot, or whether it is overheating or it is heating normal heating, right? Like the temperatures, and you can check the fan speed, fan condition. So in order to perform system specific check, system specific, platform specific activities, Intel came up with this mods. And they call it system management mode. Okay, so what happens actually when like for example, let me tell you, let me draw a small diagram over here. Let's suppose that your CPU is currently operating in protected mode, and somehow we'll see, is due to some interrupt or some other thing, your microprocessor or CPU is going to switch to system management mode. So what happens, okay, when you switch from one mode to another mode? So definitely, whether you are switching from mode A to mode B, or going back from mode B to A, or let's say some other mode, so you have to, the processor store the current state of the system in some storage, in memory. So what happens, SFM, with the help of, let's say due to some interrupt or some event that occurred, and microprocessor has to switch from protected mode to SMM mode. So in this scenario, when it will be shifted to SMM operational mode, it will actually have a separate memory segment, a separate memory segment that will be available to the code which is you can say that which is available in SMM mode. What happens, the SMM, as we say, it is system management mode, okay, used to perform some system specific activities, system specific health checks and monitoring of the microprocessor and some other features, some other hardware. So what happens, the software is actually stored in the firmware. So when you receive an interrupt or some other thing, okay, what happens when you receive an interrupt or some other event and your processor is shifted to SMM mode? So the code which is residing in the firmware of the of the microprocessor start executing and switch to SMM mode. And when the microprocessor is switched to SMM mode, right? So what happens, whatever is running before switching to SMM mode, all will be saved in some at some memory location, okay, in some protected memory area. That will be separate from rest of the memory. And apart from that, the available RAM which will be available, accessible RAM which will be available to system management mode, will be completely separate. As I have written over there, SMM allows the processor to execute code from the system management memory that is completely separate from the regular memory. So it will not intermix, allow intermixing of your applications and the SMM software. So it will be even completely transparent to operating system, right? So what happens, due to this this feature, there are certain things that will be imposed that we'll see shortly. One more thing which I want to tell you over here, when the operating system switch to system management mode and start executing the firmware, that firmware will be actually executed with very high privilege. Like you can say that, like I'm just giving you an example, like in Windows you have admin privileges, admin role. So just assume, for the sake of argument, the code of SMM firmware, okay, actually start executing with very high privilege like admin. It is not admin, where there's a concept called privilege level, and ring 0, ring 1, ring 2. So it is the highest privilege in which the SMM code actually execute. And later we'll see, due to this problem, I'll have to clear all these things. Due to this high privilege issue, there are some certain rootkits are also available that can compromise your machine. Let me clear. Sorry. Okay, the SMM is also abused to run high privileged rootkits. So rootkits are malware software. Since your operating system, your machine microprocessor actually switched from protected mode to system management mode, and system management mode within system management mode, the microprocessor is executing this proprietary firmware, and it has full access to the memory, although it will be separate from that region of the memory will be separate from the operating system memory and the application memory. But since it is running under high privilege, so attackers and hackers have used this particular vulnerability to compromise and install rootkits within the firmware, and even they can infect the firmware, and they can basically install other exploits. Okay, let's move to the next slide. So why SMM was used or was developed? As we discussed in the earlier, it was primarily used for power management feature back in those days. System security, provide some security. So it is used for system health monitoring, as I said. Okay, it is used to perform again power management features. But these days, power management features are generally handled by the operating system itself. Also, this is a non-exhaustive list, right? It can emulate PS2 mouse and keyboards. Okay, it can emulate or forward calls to trusted platform security, and the list goes beyond here. So these are few applications area where why SMM was developed and used these days, and it is still available in most IA32 processors. Okay, so here I just try to basically mention how you can, microprocessor switch from protected mode to system management mode. It actually happens when when you receive an interrupt. The processor receives an interrupt, okay, on external interrupt pin, and then it's switched to protected from protected mode to system management mode. Let's say this is your CPU, okay, and this is your interrupt pin. Okay, so when a processor receives an interrupt on this particular pin, and for example it was this CPU was executing in protected mode at that time, so it will switch to system management mode. Or there is one more technique or one more way, like when SMI, system management interrupt, is received from epic, not from the interrupt pin. And I guess you have already covered interrupt labs in assembly, so I hope you will have a good idea about what is an interrupt, what is an interrupt service routine, ISR, etc. And again, you can see that this is a very important point. By design, the operating system cannot override or disable the SMI, system management interrupt. So this is a point of concern, right? If you receive an interrupt on SMI, so operating system cannot ignore it. It must switch from protected mode to system management mode. For further reading, Wikipedia has good resource on system management mode, and I would need 2 volunteers during the class when we'll have QA session, and I'll give tasks to them regarding further reading about system management mode. I mean, as we previously had a couple of presentations regarding, Java execution and execution environment and .NET and other demonstrations. So during the class I'll need two volunteers, and I'll request them to prepare a short presentation. And because we'll discuss this thing in the class, but if you remember, the grading and evaluation will be different in this semester, so we'll have to, I think this will be this will add to your grading. Like one by one I'm planning to give presentation tasks to every student. Okay, so okay, up to now any questions you can post it on forum, okay, or in the comments section or during the lecture. Okay, before going into the next section, let's discuss about the available mods in Intel 64-bit hardware, right? So Intel 64-bit microprocessor has added one mod, that is IA32 extension mod, right? And it has two sub mods actually. The one is for the compatibility purpose, compatibility mod, and one is a pure 64-bit mod. So in the compatibility mod, this is the both of these mods are actually IA32E extension mods, sub mods. Okay, in the compatibility mod, what happens, you can actually run 16-bit and 32-bit legacy applications, okay, without recompiling them. And compatibility mods support all of the privilege levels that are supported in 64-bit and protection mod and protected mod. And actually, the purpose is very same. Okay, you cannot actually, from the business or marketing point of view, like for example, you had a product, let's say that in year 2018 you had a product like product A. Okay, now in 2019 you came up with a new product A1, for example, and in 2020 you have come up with A2. Now what happens if in A2, if you do not support A1 or A, what will happen? Customers will not buy A2 because there are a lot of legacy applications that need to be operate, and we usually do not, like in organizations, we do not upgrade system more rapidly. It's not like that the Intel has come up with a new hardware and everyone is going to replace the existing hardware. There are a lot of things like compatibility, like budgetary things, like security and security challenges, like and operational issues as well. So so Intel, that's why Intel supported Intel still support 16-bit applications in even if you have a 32-bit operating system with and 32-bit hard microprocessor, and this can be achieved with the help of compatibility mod. Okay, one thing I think I did not discuss during the protected mod. Generally in protected mod, okay, when we talk about protected mod, you usually have access to 4 GB of memory, 4 GB. Remember, in real mod you could have access only 1 MB, and in protected mod you have 4 GB, and even you can go beyond that 4 GB limit as well. So if your microprocessor is running in compatibility mode, so the application can access only the first 4 GB of linear address space. We'll see what is a linear address space in the next lecture. And yes, we'll see physical address extension also. And if we want to go beyond the 4 GB limit, 4 GB capping of protected mode, we'll have to use the physical address extension technique. These both these terminologies like linear address space and physical address extension we'll see when in the next lecture, or probably in the next lecture. And 64-bit submod is basically a mod for 64-bit operating system and 64-bit microprocessor. And and the one new thing, like 64-bit mod extend the number of general purpose registers and SIMD extensions. Anyone has an idea about what is SIMD extension? What is SIM? SIMD stands for single instruction and multiple data. Okay, we'll discuss about SIMD in detail in next session. So actually what I planned, I'm planning to make videos a little small, smaller than the previous ones, because I guess previous videos which I have recorded were a bit lengthy. So I'm trying to keep videos smaller and and breaking them into multiple parts. Okay, thank you very much. Thank you. Take care.